Hello everyone and welcome to the session 5 of Unit 6 Unconventional Machining for the course Machine Tool Technology. So in the today's session we are discussing all about laser beam machining. So in case of laser beam machining, which is also known as light amplification by stimulated emission of radiation. So laser stand for light amplification by stimulated emission of radiation. So this beam is used for increasing the temperature of the workpiece. So this high focused laser beam, which is coherent in nature. Coherent means uh, which is having a equal wavelength with the time. So this the property of this laser beam is makes the laser beam more stronger than other light sources. So the laser beam having coherent properties, which is makes the laser light for using machining process. So this laser light with a high velocity and narrow beam, it strikes with a high velocity to the workpiece, which will increases the temperature of the workpiece and removes the metal from the workpiece. So the ruby crystal or the optical transducer, which is also known as ruby crystal, is used for producing the laser light. Uh, the laser, being coherent in nature, has a specific property of generating high power density. So the power density is higher in case of laser light compared to other light sources. There are several types of lasers used in manufacturing operation: carbon dioxide, ND YAG, and ND glass, ruby, examizer laser. The LBM user, the laser beam machining, uses light energy of laser beam, so to remove the metal by vaporization and ablation. So the laser beam machining uses light energy of the laser light for increasing the temperature of the workpiece, so to remove the metal by means of vaporization and awash. The working principle of the laser is very simple. So I'll explain here. So it consists of a flash tube, a xenon flash lamp, so and a ruby crystal and a magnetic lens here, and this is the workpiece, the power supply. So what will happen when you give power supply to the this flashlight, which is xenon, which produces monochromatic light with a high density. So when you supply the electric current to this flash tube, the xenon flash tube produces high monochromatic light with a high intensity. So this high intensity monochromatic light is focused towards the ruby crystal. You can see this flash tube is turned on when the power is supplied to this the flash tube. The xenon flash lamp causes the high density of monochromatic light, which will passes through the focus towards the ruby crystal. On the both side you can see it will focus us towards the ruby crystal, which energizes the ruby crystal. So this lamp light causes the ruby crystal to energize, and it will generate the laser light. So the laser light is focused, then passes through the lens, so that will causes the laser light causes the decreases the divergence of the laser beam and made to focus towards the workpiece with a high power density and narrow narrow beam size. So this magnetic lens makes the convergence of the laser beam and making the beam to focus towards the particular portion of the workpiece with a high velocity. So when this high velocity laser beam is strikes the workpieces, it causes the increases the temperature of the workpiece and melts the workpiece, and that will remove the material from the workpiece. A very simple operation of laser beam machining. So in construction, it consists of a ruby crystal, which is used to produce the laser beam. So we have a flash lamp, which made up of xenon flash lamp. So when and a magnetic lens. These are the and the power supply. These are the only four important parts of the laser beam machining. When the power supply is given to this the flash tube, so it will generate the monochromatic light with a high intensity. So high intensity of monochromatic light is generated by this flash tube for a small period of time. So this monochromatic light is focused towards the ruby crystal on both sides. So this ruby crystal will energize us because of the xenon flash lamp, and it will energize and it will generate the laser light. So this laser light is focused towards the lens that will makes the laser beam focusing towards the it will remove the divergence of the laser beam and make the laser beam narrow and impinging with a very narrow uh, density, and with a high velocity it will strikes the workpiece, that will increases the temperature of the workpiece and removes the material from the workpiece. This is the working principle of laser beam machining. Then advantages of laser beam machining. Advantages of laser beam machining are micro holes can be drilled by this process. Materials which cannot be machined by conventional methods are machined by LBM. There are no tools, no tool wear. There is no tool at all, and there is no tool wear. There are no burns and machined surface. Application of heat is focused, so rest of the workpiece is less affected. Precision holes and cavities are obtained. The application of heat is in a particular part only, it will not supply to the whole material, so the other parts remains safe without any change in the metallurgical properties. Initial cost disadvantages is initial cost and operating cost is high, recommended for some special operation only. Production rate is very slow, cannot be used for high refracting metals like aluminum, copper and titanium. Skilled operator is required. The holes producer may have taper. So these are the disadvantages of laser beam. We have application of laser beam is used for performing different machining operation like drilling, slitting, slotting, scribing operation. It is used for holes of small diameter with a diameter up to 0.025 millimeter, making complex profile which is very difficult to produce in other processes like in circuit boards, PCB, integrated circuits, chips, machining of mechanical components of watch, smaller machining of very hard materials. So before going to end this session, I will show the simple video of laser beam machining, how it works. So
Principle. In this machining process, as the laser beam strikes the surface of the workpiece, the heat energy from the laser beam is transferred to the workpiece. This heat energy absorbed, melts and vaporizes the material from the workpiece surface. Construction. The laser beam machine consists of following parts. Power supply. It requires the power supply of 1 to 10 kilowatt. A high voltage power source is used to produce light in flashlight tubes. Flash lamp. Flash lamp or flash tube is used to charge the electrons of the atoms in the crystal, which is also called as pumping medium. Capacitor. Capacitor is used for operating the laser beam machine in pulses. Pumping medium. Pumping medium, in this case, is a ruby crystal, which has a large number of atoms, which when absorbs the energy, their electrons produce photons. Working. When the switch is turned on, a high voltage power supply is applied across the flashlight or flash tube surrounding the pumping medium, in our case it's ruby crystal. As the light is powered on, it emits high energy photons. These photons are absorbed by the ruby crystal. This absorbed energy causes most of the electrons contained in the atoms of the ruby crystals to be excited at a high energy level from its ground state. After a short duration, as the electrons from high energy level comes to ground state, they emit photons. This emitted photon stimulates the excited electrons to return to their ground state, thus producing more photons as they return to their ground state. Thus a pair of photons are obtained by utilizing one photon. Thus, we call this process as amplification of light using stimulated radiation. As the photon's concentration increases, the laser is formed. A 100% reflective mirror is used to reflect all the photons back to the crystal, whereas a semi-reflective mirror reflects some of the photons back, and escaping photons through a semi-reflective mirror forms a high-energy laser beam. Then a lens is used to focus the laser beam onto the workpiece to be machined. Interaction of laser and workpiece produce a large amount of heat, thus vaporizing the surface of the workpiece, thus cutting grooves of various shapes, or cutting the workpiece. Application of laser beam machining process. Engraving, welding, surface treatment, cutting, drilling, It is also used in shipbuilding, automobile, aerospace, steel, electrical, and medical industries for precise machining of the various parts.